Welcome to this RevisionKing video on electrolysis of molten ionic compounds. Here's a key definition. Electrolysis is a splitting up of an ionic compound using electricity. Key terminology. Electrolysis takes place when the ionic compounds are in a liquid state or in an aqueous solution because ions are free to move about and carry the current. This means they're delocalized. The liquid that is decomposed by electrolysis is called electrolyte. When ions lose or gain electrons at the electrodes, they are discharged. Electron movement. During electrolysis, negative ions move towards the positive electrode, which is called the anode, and lose electrons to form non-metallic elements. Positive ions, however, move towards the negative electrode, which is called the cathode, and gain electrons to form metallic elements or hydrogen. For example, molten potassium chloride forms chlorine at the anode and potassium at the cathode. This is because chlorine forms negative ions, and potassium forms positive ions. Each ion is attracted to the electrode with an opposite charge. Here's a higher tier topic, half equations. The reactions at each electrode can be represented using Ionic half equations. Here are the general half equations. At the cathode, Mn plus Ne gives M. At the cathode, the metal ions gain electrons. This is reduction. At the anode, 2xM- gives X2 plus 2Me-. At the anode, the non-metal ions lose electrons. This is called oxidization. To balance half equations, remember that ions need to gain or lose a specific number of electrons to get rid of their charge. Reduction and oxidization. To determine whether a reaction shows oxidization or reduction, remember oil rig. Oxidization is loss of electrons and reduction is gain of electrons. Here's a diagram. Here are some exam practice questions. What is formed at the cathode and at the anode when molten calcium chloride is electrolyzed? Calcium is formed at the cathode and chlorine at the anode. Give the equations for the reactions at the electrodes. Here is the equation for the cathode, and here's the equation for the anode. Thanks for watching this video by RevisionKing on electrolysis of molten ionic compounds. Please don't forget to like, comment and subscribe. See you next time.